Hello everyone, and thank you for joining today's webinar organized by Sardina Systems and Storpool Storage in a cooperation. Today's webinar is called Kubernetes as a Service, and we will talk for the new revolutionary standard for containerized enterprise workloads. The webinar will be presented in a cooperation of Storpool Storage and Sardina Systems, and we will have two presenters today. On Sardina side, we have Dr. Kenneth Tan. Hi, Kenneth.
Hi.
And on Storpool side, we will have Nikolai Tenev. Hi, Niki.
Hi, everyone.
A few organizational things in the beginning. The webinar will be approximately 45 to 50 minutes with a 10 minutes Q&A session at the end of the event. Meanwhile, if you have any questions, you are free to submit them in the chat window on the right side. So just don't hesitate, type your question, and at the end we will respond to your question. The webinar will be recorded. We're also live streaming on social networks, so take your place and enjoy the event. Kenneth?
Thank you, Yvette. Hi, everyone. So today, I want to talk to you about Kubernetes as a service and offering that we are bringing to the market together with our partner, Storpool. Let me try to forward these slides here. Yeah, got this. So my name is Kenneth Tan. I run the technical operations within Sardina Systems. And together we have Niki Tenev. Niki?
Hello, I am Nikolai Tenev. I'm solution architect in Storpool Storage. So it's very pleasure to meet us together.
Thank you.
Yeah.
So a few words introducing who we are. Sardina, we are an OpenStack Kubernetes software vendor. We provide a smart cloud platform built on OpenStack and Kubernetes to provide flexible, scalable clouds. What you'll find as a message throughout our offering is that we aim for production, we aim for enterprise-grade production. So you see this thread running through how we build our product, how we build the offering as well. We are a relatively young company, founded in 2014. The founding team came from supercomputing, finance, defense, and telco, understanding the challenges and the complexities of building, operating, and scaling very large scale systems. We're very much a European company. While the companies in the UK, in Germany, and some of our colleagues are in Romania, Russia, and elsewhere. And we're quite proud to say that along the way, we've managed to win a number of awards, including the DCD Global Awards, the IDC HPC Innovation Award, amongst others. And we're a very partner-friendly company. And you see on the bottom right a number of our partners.
Okay, let's just talk some few words about Storpool. Storpool Storage is a software company that's building high-performance data storage solutions. These solutions run distributed on a multitude of standard servers and are managed by intelligent software. Of course, by standard servers, we mean enterprise-grade servers, not just old or refurbished computers. Our focus is on integration with the leading new IT stack platforms like OpenStack, KVM, Kubernetes, and so on. Yet, Storpool still supports legacy stacks like VMware, Hyper-V, Zen servers, and so on. Storpool products is not just a piece of software that comes with support in case of emergency, but it comes like a fully managed storage solution, which includes planning with the client, full network and hardware tests, remote installation, consistent monitoring, 24/7 mission-critical support, proactive issue resolution, non-disruptive life upgrades, and of course, service level agreements. Storpool was founded in 2011, and now, almost 10 years later, we are one of the few cash flow positive storage vendors in the world, and the company has triple-digit growth. Built from the ground up, the Storpool's mission is to make the storage more straightforward and more affordable for the companies that building clouds by delivering the best distributed storage system. Can you change the slide, please? Thank you. As an infrastructure component, Storpool is a full replacement solution for the storage layer, as our goal is to build and deliver the best, fast, and reliable primary block storage system. Storpool replaces the traditional technologies like SANs, NAS, all-flash arrays, or any other less efficient software storage solutions. Even the smallest Storpool cluster is available to achieve millions of IOPS in 0.2 milliseconds latency, better than any local SSD storage. Additionally, the system is easily scalable. Just add more or higher capacity drive, or even the whole servers, and all this happens live without the interruptions in the storage operation. Thank you, Kenneth.
Thank you, Nikki. So now, first off, I think it would be useful for us to set the scene and look at Kubernetes and the constructs of the Kubernetes as a service offering. Now, we have at times heard mention of Kubernetes in a manner that makes it sound like Kubernetes is new. Kubernetes is really new. Kubernetes is the sexy thing. Is it really new? Well, if we go back only to the point where Google started working on process containers, it was building on prior works by SGI, Bull, amongst others. And this, of course, ignores all the prior works that go back several decades before. And fast forward a little, we see that Kubernetes announced in 2014. And fast forward further, we see that in March 2018, that was the first beta version of Kubernetes 1.10. And along the way, there is a lot of development, there's a lot of community efforts, community interest in taking Kubernetes to where it is today. So now in this offering, what are we looking at in terms of the building blocks? So as mentioned, we're building on Kubernetes, as that's the topic that we're looking at today. Kubernetes running in conjunction with OpenStack. With OpenStack providing the platform management and for both virtualized and bare metal environments. And with this, we also get multi-tenancy support out of the box. And on the storage side, we're leveraging Storpool to provide block storage and backing store for OpenStack and Kubernetes. So a quick glimpse of what's possible. Today in enterprises, we see that often users want the flexibility of having effectively root. But at the same time, for the operations team, root is rather risky. So what we see here is a managed power of root. Encrypted disks, certainly. And what we'll look at in a moment also is efficiency. How do we eliminate wastage at source? Flexible networking, as well as flexible integration with various capabilities such as load balancer, GPUs, accelerators, and flexibility of integration between VM-based and containerized workloads, so on and so forth. So what we are very excited about in this platform is that we can provide operators with a full cloud solution with automation tools covering the entire life cycle of the Kubernetes cloud operations, from deployment into operation into upgrade of the full system, including the underlying OpenStack. Not only that we are able to provide an efficient system for the workloads, we're also able to optimize placement of where the workload needs to go and the right placement, the right matching of resources requirements to the workloads. Of course, within an enterprise, it goes without saying that we need to build for reliability. So we've engineered for HA by default solution throughout. One thing that we like to say is that we don't build toys. This is built for production from the outset. Also, Sardina, we bring a number of AI-driven technologies to drive high efficiency, as well as to drive smart fault handling. On the efficiency side, we're able to improve energy utilization, improve server utilization, and to drop the total TCO by as much as 60+%. So when we're looking at Kubernetes as a service, of course, the first question is, what's the hardware? Here, we're flexible to either implement it on client hardware or lease hardware from one of Sardina's hosting partners. And as for hosting, the hardware can be on-prem at a customer site or at a colo site. Or indeed, if it is leased from one of our hosting partners, it would be located at our hosting partner's facility. And when it comes to deployment, Sardina FishOS and Storpool would be deployed jointly. And assuming that we are prepared for the implementation, we've planned it all out, then the full deployment can be done remotely, fairly rapidly, within a day from hardware availability. How can we do this? It's automated already, out of the box. And when it comes to operations, the system can be fully managed, professional operator and monitored, either by Sardina or by one of our operations partners. And it can be integrated with enterprise systems and processes, while at the same time providing full visibility for the enterprise operations team. We talk about optimized cost performance. We can have Kubernetes running on both VMs and bare metal according to the requirements of the workload. And at the same time, being able to take advantage of high performance storage, high performance networking. It's a system that you as an enterprise can scale as you grow, add compute, add storage to match your workload growth. And when the time is right for your enterprise, you want to take the operations in-house, you can do that. We can transition over to you. So how does the solution look like? On the left-hand side, you see the building blocks of Sardina FishOS. And on the right-hand side, you see Storpool's building blocks. I'll talk a little bit more about the FishOS part, and I'll leave Nikki to talk about the Storpool part. Kubernetes in this system is enabled through an OpenStack component called Magnum. And we leverage the core OpenStack components such as Nova, Keystone, Cinder for block storage, authentication with Keystone, bare metal with Ironic, so on and so forth. And in addition to this, we couple them with the workload managers, health engines, monitoring, log management, bean counter, capacity planning, so on and so forth from Sardina side. And as the organization grows, one of the things that customers often find very useful also is service management. And this is also an included component within Sardina FishOS. Nikki?
Thank you, Kenneth. So a little about the Storpool architecture. In general, one Storpool cluster is made up of 3 layers. The first layer is the storage layer at the bottom of this chart. It is formed by the storage servers or the servers where the storage devices like hard drives, SSDs, or AVMs are installed. The storage servers combine their capacity and the performance and provide the compute servers with the virtual drives. The second level is the client or compute layer in these charts on the top. So this layer is formed by the servers to which the Storpool volumes are exported like a virtual drives. These servers are Kubernetes workers or hypervisors in the client infrastructure. With Kubernetes, the Storpool volumes are presented as CSI persistent volumes to the pods, and with hypervisor, the Storpool volumes are delivered like virtual disks to the virtual machines. And the third layer is the networking. It is a highly available, low latency network layer, for example, formed by 2, 10, 25, 40, or 100 gigabits per second switches with a redundant connection between them. So each member cluster, server, or each cluster member, server, or client has one connection to each switch. So in case any links go down, there will be no interruption in the storage operations in the whole cluster. So next, let's take a look how Storpool integrates with Sardina FishOS in our joint on-premise Kubernetes as a service solution. The first example is when Kubernetes is run in virtual machines. As Kenneth mentioned earlier, FishOS is based on OpenStack. So in this case, the provisioning and the management of a VM's virtual drives go through the integration between Storpool and OpenStack. When a Kubernetes pod requests a persistent volume, it is delivered as a virtual drive to the virtual machine where the pod resides. Each virtual disk is an OpenStack Cinder volume that is backed by the corresponding Storpool volume. The creation, management, and the provisioning of these volumes happen through the requests from the OpenStack to the Storpool's API. Please. Thank you. In the second example, the Kubernetes workers are bare metal servers instead of virtual. The iteroperation will be very similar like the previous example with some small differences. Instead of virtual servers provided by OpenStack Nova service, now the Kubernetes workers are provisioned and managed by OpenStack Magnum service, which uses heat to orchestrate the OS images that contain Kubernetes. In this case, Kubernetes persistent volumes are provisioned and managed through the OpenStack CSI driver, but again, the Kubernetes persistent volumes are OpenStack Cinder volumes that are managed by that are backed by Storpool volumes. And the third example is when OpenStack Ironic provisions and manage bare metal servers. And after that, an external Kubernetes management system configures and joins these servers like as a Kubernetes workers. In this case, Kubernetes persistent volumes are backed by Storpool volumes, which are created and attached to the Kubernetes workers through the Storpool native CSI driver. Of course, these three options do not cover all possible ways in which an on-premise Kubernetes cluster could be built with the Sardina Fish OS and Storpool. Moreover, Storpool is flexible enough so one storage cluster is able to serve simultaneously multiple Kubernetes or KVM cluster. So there is no need to create a new storage cluster for each separate computing cluster. Thank you, Kenneth.
Thank you, Nikki. So I want to highlight this Sardina Storpool Kubernetes as a service offering. This is providing enterprises with a number of key benefits. Now, just to go back a little, we mentioned earlier that we have an environment that is highly customizable, efficient, flexible, and this stretches the full spectrum from the users wanting of root encrypt disks to efficiency from a operator standpoint, managing and eliminating wastage, and integration with enterprise processes, integration with customized hardware, accelerators, so on and so forth. Now, let's delve into this a little bit further. What do users want? First and foremost, users want reliability. They want the system to be up at all times. And users also want updates to simply be transparent. And put it very simply, this whole theme of reliability comes down to it should just work. And what else do users want? Users want it to be secure. In essence, users want it to be my stash of stuff should always be private, mine, and only mine. And users want strong security segregation so that when there is any escape, there won't be any risk of escape from one tenant to another. And users also want flexibility in the form that they want to be able to define networks whichever way that they want. And I want software, any configuration. And users also want strong run now policy. So what does this mean? When the workload is to be executed, it should be executed now, not sometime in the future, not certain waits, no, now. And users want this so as to shorten the time to result. And at the same time, users also want the operation side to provide pre-canned machine images. They want service catalogs, application catalogs, and at times they may want shared data. And last but not least, they wanted self-service and a pay-as-you-go model. So now, how do we enable this within FishOS and Storpool offering? In relation to security, we ensure that the Kubernetes pods are segregated between the tenants. So no two tenants share the same Kubernetes pod, or share the VMs or the bare metals for the Kubernetes pods. So that in the event there is any escape from the container, you're escaping only to the VM's kernel or the host kernel. Now, I want to talk a little bit about reliability. As we know, the expectation of users that it should just work, this isn't a simple expectation to meet. And often when we talk about how to ensure uptime, I get suggestions that, hey, we can do this with monitoring. Can we? Does it really work? Let's go one step further and look at the principles behind monitoring. In monitoring, essentially what we're doing is we're probing every cycle, and if the other N responds, we say, yep, it is fine, it is alive. And next cycle, we probe again. And in the event that the other N doesn't respond, we're not quite sure why. So let's probe again. And it's still not responding. So let's probe 3 times. If it's still not responding, let's declare problem and call the operator. But by that time, the downtime is already felt by the service consumer, i.e. the user, therefore impacting the experience. So it's no longer just work. It is already not working. Now, what we do at Sardina is to take this one step further by detecting, having preemptive determination that a particular part of the system may be ill. So not necessarily having trouble, but it could be ill. Something is possibly wrong, and thereby providing the operator with preemptive notification. In relation to workload management, we all know that workloads have their high and low times. Whether the high and low is within a period of an hour, a day, a month, a quarter. There are highs and lows. FishOS detects these highs and lows through Workload Manager, this block in the middle here. And we determine the optimal packing of the VMs of the workloads. This is done transparently. And when we repack, we use live migration for this purpose. This enables us to match the resources to the demand at any time. And by doing that, you as the operator end up saving money. For operators who are offering an onward service to users whom they bill, you also benefit from a component called bean counter at the bottom left. Here we provide a CSV output to enable you to feed into your billing system to bill the user, and it's very flexible to bill whether per user, per VM, per Kubernetes pod, so on and so forth. So let's look at a number of use cases. In this example here, there is a case whereby the customer is doing certain machine learning workload with some self-provisioned bare metal nodes with GPUs to drive high performance. And they have mixed VM-based workloads also with GPUs passed through into, and this gets them higher density without compromising on performance. And the client, in turn, leverages the system to achieve multi-tenanted Kubernetes with strong segregation and very strong security assurance. And the system is integrated into the service consumer's workflow pipeline through a virtualized network. And in another case, this is also a machine learning system. Here, the client has a need for encrypted storage volumes to handle confidential data. And similar to the first system, the client also had GPUs passed through into the VMs through PCI pass-through. Now, one thing that's different in this system is that the client has mix of GPU workloads and non-GPU workloads. So this enables us to schedule nodes with regular VMs and allowing those VMs to use the CPU, use the memory, when the GPUs are not in use. And then when there is GPU-based workloads, we then live migrate them away to clear those nodes for the GPU-based workloads. The system here, the entire system is actually being used for automated workload provisioning. So the creation of the pods, the initiation of the workloads, they are fully automated. And in a third case, this is a bioinformatics case, whereby the operator provides a set of ready-to-use images, and users only bring their own biological data sets. The system, they provide tools and workloads, tools and workflows for very high memory requirements computations. with some of them requiring up to 3 terabytes of RAM and over 100 CPU cores. Integrated with it are multiple storage solutions with SSD-based ephemeral disks, data volume, so on and so forth. And the output of the system is then ingested onward for further processing. And in another instance, whereby we're looking at a data matching and data normalization case. Now, here, the client has, again, self-provisioned environments. The development groups, the operations teams, they are able to self-provision those environments, and they're also auto-scaled via API as the workload grows. Now, in the domain of data matching and normalization, historically, it's very much a manual process with much human intervention to scan through large lists with fairly poor quality data. And you then alert downstream processes as to certain things that you want to be aware of. The client here then want to move away from that with a solution that standardizes and matches data automatically. And they're able to remove various subtle differences related to data accuracies, transliteration errors, spelling errors, and so on and so forth. This enables the customer service teams to have humans navigating through large data volumes. And it's also, as I mentioned a moment ago, demand-driven. And as the workload grows, the self-provision environment also grows. And I have a couple of other cases. So this next case, the client is really going from data to execution strategy with the system. So they have self-provisioned VM and Kubernetes clusters. And with each code commit, it could then trigger launch of containers and launch of Kubernetes clusters. And this enables them to run experiments very rapidly. And the client, due to the sensitivity, they leverage the strong security that's provided by KVM and the strong network security of Open vSwitch. And this enables them to try out various strategies, and as they narrow down on certain strategies that they want to execute, it can then be moved straight into production execution. And the last case here, this is a system where the client also have self-managed auto-launch applications. And some of the workloads do require specialized hardware. And these hardware are passed into the VMs also through PCI pass-through. And at certain times of day, they also need a certain number of cores allocated for high priority workloads. And during those times, the lower priority workloads needs to be moved out to make space for this high priority workload. And we can achieve this using FishOS Workload Manager. And we can also craft the energy profile fitting the dynamic workload environment. And along the way, users that need share historical data for their analysis, that can also be catered for. So I hope these few cases give you some idea of what can be accomplished and what the system is able to do. Let's open for some questions.
Thank you, Kenneth. It was a very impressive presentation. I hope you can all hear me back. Can you hear me? Kenneth?
Yeah, we can.
Okay, yeah, so thank you very much to Kenneth and to Nikolai, our speakers at today's event. It was very interesting presentation. And now we will go to the Q&A session. We have a few questions here on the webinar chat, and we have a few questions from the online streaming. So first question is from Matt Iris. Hi, Matt. Nice to see you here in the webinar. And the question is the solution usable by public and cloud providers, or it's primary for the enterprises?
I'll try to answer the question. So it can be used both by a public cloud provider and a private cloud operator. Now, from an infrastructure point of view, I'm sure you can agree with me that there is very little difference between operating a public cloud and operating a private cloud. The key difference being whether the operator of the cloud and the service consumer of the cloud belong to the same organization or not. So it's basically a bill paying question. It's less so of a technical issue. It can be done for both public cloud and private cloud. I hope this answers the question.
I also hope so. And another question from Matt is the solution price compatible to ONAP? I'm not sure if Kenneth and Nikolai are familiar with the pricing of ONAP, but maybe if you can share a few words about it.
I would say that we are competitive without me looking at the quotations that you may have from ONAP, but let's talk offline and let's discuss pricing. But I'm very confident that we can give you something that is very competitive price-wise.
We'll share the contacts of Kenneth and Nikolai at the end of the webinar and also as a follow-up. So if you have any questions in terms of pricing, you're free to get in touch with them. The next question is maybe more for Nikolai, and it's what are the main advantages of Storpool as a storage system if you need to compare it to other storage systems on the market?
Okay, it's not easy for me to select just few. There are a lot of them. First of all, it is a modern storage system built from the ground up to be the fast and the best. There are no legacy the code or old standards that we need to support long time. The system has most advanced end-to-end data integrity with the free copies of information on different servers. So in case a whole server down, not just on disk, a whole server down, you know, don't experience any interruption or data loss in the cluster. Efficient copy on write protocol, efficient snapshotting clones, zero detections, multi-stack and multi-platform support, built-in backup and disaster recovery, advanced monitoring. I think that there are enough. You agree with me?
Thank you, Nikki. One more question here from the streaming. How many servers do we need to get started with the solution?
Okay, the minimal servers to start are 3. This is in our system requirements, and this is the minimal number of servers that give you the optimal performance for their number, with some protection like split brain or network outages, etc. So the 3 servers are the minimum.
Thank you, Nikki.
And on the Stardina side, similarly, the starting point is 3 controllers, the same controllers that will also run the various other management function. Usually when the system is small, you can also co-locate the balancer function on the same nodes. But as your system grows, we would suggest that you look at segmenting out the balancer function onto 2 separate nodes. And of course, you can add the computes as you scale. At times, we also get asked, so 3 controllers will support how many computes? I would say that is highly workload dependent. We have seen customers that are running 3 controllers to manage in excess of 300 computes. And at the same time, we've seen customers running 22 controllers to manage circa 250 computes. So it's really workload dependent.
Thank you, Kenneth. And one final question is, how big should my company be in order to plan a migration to a Kubernetes as a service platform? Like, is there any minimum size? So when is it meaningful to implement a Kubernetes as a service platform?
I'll try to answer this question. So I would say there isn't necessarily a minimum size, but the question is more of, do you need it? And by that, I mean, does your workload fit Kubernetes well, or does your workload fit a more of VM style environment? And the Kubernetes part, if it fits, then as you move into a Kubernetes style of managing workloads, we can help you implement the system and build it out and have it managed to grow alongside your business.
Yeah, that's a good point of view, that you really need to think whether it makes sense and what you actually need to achieve, and afterwards start to think about the migration and make your migration plan. Nikki, one question here from the audience. Does Storpool have an integration with Kubernetes?
Yes, Storpool has a native integration with Kubernetes with a native CSI driver. So we're fully compliant with the CSI standard. Yeah, that is the short answer.
Thank you, Nikki. And also I would like to add that recently Storpool became a member of the CNCF Foundation, so you can really expect some new and interesting things from us together in Sardina, of course, as partners. Because we're almost running out of time, I will go to the final question in the chat. Will you please give a few examples of workloads more suitable for VM-based deployments and workloads suitable for containers?
That's not a simple question. I would say that if the workload works in a traditional VM, traditional bare metal, do you really benefit from re-engineering it? If there is business value in re-engineering it, yes, then it makes sense. And I'm telling you this from wearing a technical person's hat.
Thank you, Kenneth. As final words, I would like to say thank you, everybody, for joining the webinars, and thanks to our speakers. And I see we actually have another question. So providing a public cloud with FishOS, how can foreign tenants configure their own Kubernetes cluster?
Sorry, could you repeat that question?
It's providing a public cloud with FishOS. How can foreign tenants configure their own Kubernetes cluster?
So I understand the question to be, how can an external tenant configure their own Kubernetes cluster?
Yep, should be it.
So when a tenant requests for a Kubernetes cluster through FishOS, essentially what happens in the background is that a set of VMs or bare metal nodes are provisioned, and then using heat, the Kubernetes is then deployed onto those nodes. So the pods are initiated, etc., etc.
Good. As for Thomas, who asked this question, we will definitely submit the email of Kenneth to you so that you can get in touch with him for more details and discuss the specific use case. And as we're running out of time, I would like to say again that thank you for everybody being here. We will follow up with an email with the webinar recording. Stay tuned for our latest projects from Sardina and Storpool in our blog, in Sardina's website, and follow us on the social channels, especially on LinkedIn. We have interesting things to share.